So we're going to get started at this point. Hello, everyone. My name is Michael Clark. I'm an IT operations and tech industry consultant with Renaissance Tech and Media. At Renaissance, we help companies and organizations struggling with cybersecurity challenges to operate more safely and efficiently in the world of hybrid multi-cloud computing. Today, I'm here with Brett Hamill, Senior Solutions Architect at Genians, a company that has helped over 1,600 customers around the world since 2005 to secure their network edge. Over time, Genians has developed an innovative framework for solving cybersecurity challenges across multiple industry verticals. Today, we'd like to share the most common of these challenges and explain how Genians resolves them by leveraging Next-Gen NAC, or network access control, capabilities. With that, I'm going to turn the mic over to Brett to begin today's presentation. Take it away, Brett.
Thank you, Michael, and thank you everyone for joining today. Just a little bit of background. We have this new webinar series. This is the first installment of that series. We're going to be focusing on NAC in the IoT era, but also we're going to give some overview about NAC, what NAC is, how NAC is relative to cybersecurity plans, how NAC architectures differ, as well as some product overview. But because we have such a wide audience today, we'll be covering things generally from a high level, as this is the first of the webinar series, the first installment. And then subsequent installments, we're going to be doing deep dives on several of the topics that we talk about today. So we'll go ahead and get started. A little bit of background on myself. I've been in the network access control industry for about 16 years. So those familiar with the industry, that's roughly around the time the industry really got off the ground. And with that said, we'll get started on the webinar, and we will cover a little bit of background regarding Genians. So Genians has been around roughly as long as I've been in this industry, since 2005. So to put that in perspective from a network access control timeline standpoint, right towards the end of 2004 is when a company you may have heard of called Cisco purchased a company called Perfigo. And shortly thereafter, they turned that into Cisco Clean Access, and then many years later evolved into Cisco ICE. And that's what is being sold today by Cisco. So other companies have gone through similar evolutions. So Genians has been around in the industry as long as all of the major players in this industry. Very prevalent in Asia Pacific, but 3 years into a global expansion. We have 33 partners worldwide and over 1,600 customers, publicly traded company in Korea. And as you can see, we're a very technology-centric organization. 70% of our employees are actually engineers. The Genians customer base spans across just about every sector. So we do have very, very large enterprise customers with hundreds of thousands of endpoints under policy with Genians NAC. But we also have a solid presence in the SME, SMB market. Just about every industry we have customers in, and most of the IoT capabilities built into the Genians NAC solution really came from some of the larger industrial customers that have very IoT-centric environments in manufacturing, for example. All sorts of devices connected to the network that you typically would not see in other vertical markets. Healthcare is another one. So that's sort of where some of the core capabilities of Genians were born out of, supporting those types of customers. So a little bit about cybersecurity and network access control and why they're so important, and then we'll talk about how they are related. So we're coming off of really not the tail end, but we're coming off of a huge BYOD boom, which saw a BYOD challenge in how to address that. And really on the tail end of that, the IoT explosion happened. So now on top of your managed devices and your BYOD devices, IoT devices are also something to contend with. Many different companies and different markets have taken to several different approaches to address this challenge. Layering in many different security vendors and products on the network has been one approach, but because of that, now there's an attempt to consolidate those because there's so many different security solutions on the network to address this. Security compliance is, of course, driving all of the spending and the person hours that are spent on this challenge. Small businesses, just as much as large enterprises, are very much affected by some of these challenges, and these attacks and vulnerabilities can be very serious. Small companies may not be able to mitigate these as much as large companies, and some companies could actually fail. So obviously the security requirements are there, they're well documented, and it's really more about what will you do to address those security requirements and how will that be implemented.
Thanks, Brett. You know, I've always thought of NAC as being a fundamental component of an effective cybersecurity for enterprises of all sizes, really, and certainly with the constant barrage of ever-advancing cyber threats facing us these days, a solid NAC approach seems particularly critical. I mean, as we've seen with the BYOD phenomenon and now with the onslaught of IoT devices fully upon us and increasing daily, there are clearly more and more network-enabled devices being added to our environments every day, every week, every month, every year, no question. With that in mind, and for those who are perhaps less familiar with the subject, um, maybe we start out with answering the question, why do companies need NAC today?
Sure, and it's very well documented, whether it be a particular regulatory compliance or just a company's charter or their security goal, and part of their security framework that they want to mitigate risk and secure their network, why you actually need some kind of product to actually address these concerns. So, you know, some of these basic requirements and criteria really spread across multiple regulatory compliances. And these are really the core items that should be addressed and should always be part of any cybersecurity plan. So really, no matter what your industry and no matter what your goals are, you can have an overlap of all of the basic requirements that are going to be a solid foundation of a cybersecurity plan. So if you have just these basic controls in place, you have a much higher chance of mitigating risk and thwarting attacks just by doing the basics. So the question is, what kind of product is best suited to address these requirements? Really, network access control is very well suited to address all of the basic requirements. In fact, there is almost a one-to-one correlation between most basic network access control features and all of the core cybersecurity requirements that span across multiple regulatory compliances. Really, you want to make sure that you have control of all of your assets, whether they be hardware or software. Vulnerability awareness and management, of course, is important. Administrative privileges and make sure that devices have the appropriate access based on the device and the user. And then endpoint security relative to hardware and software and extended, to other devices as well is important. And last but not least, after you implement that, you of course need to monitor that and then update your plans or your configuration. So NAC is really a perfect fit to meet these requirements, more so than any other one particular tool like a vulnerability scanner or a patch management system or a SIM, etc. It really comes down to three primary steps or three core components or solutions to be able to implement some of these lower level core requirements. Surveillance and visibility is always the key component to be able to then control and then automate that environment. So network access control has these three blocks in its foundation, and used properly and deployed correctly, then you can avoid 85% of common attacks based on the security Center for Internet Security Control surveys. And network access control is just a direct fit for this. So we're going to show you actually how, and we'll talk a little bit about network access control in general.
Okay, good. Thanks, Brett. Now, obviously, with this exponential rise in connected devices, both recently and as we expect going forward, that brings with it a whole raft of potential cybersecurity issues, right? I mean, presenting new attack services for cyber criminals to try to exploit, and continually increasing the risk of regulatory and compliance liability. Yet, without knowing exactly what these devices are and without understanding what they are doing on our networks, we won't be able to ensure that they are properly secured. So, this begs the obvious question: what is the most effective way to detect and identify those devices and their various characteristics, not only dynamically, but in real time? Can you explain for our audience exactly what NAC is and how it can accomplish those goals?
Thank you, Michael. So for those of you more familiar, you may understand the concepts of NAC. You may even have a NAC system in place presently, or you may be looking for a NAC system. You may be looking to migrate, or you may understand the concept but have never implemented one. But NAC is essentially going to be a system that's going to monitor any devices that are on your network, to be able to be aware that they're on your network and to be able to identify them, classify them, properly authorize them, and give the appropriate level of privileges. You also need to make sure that you have the appropriate visibility and security policies in place to actually manage your NAC system properly. Because of where NAC typically sits in the network, it is ideally positioned to meet these requirements and to fulfill those basic needs to validate what is connecting to your network. One of the reasons that some companies do not have NAC implemented is because historically, with many legacy NAC solutions, it's challenging. So there's no doubt about it. People talk about it, CIOs talk about it, CISOs talk about it. Maybe it's a project that's never gotten off the ground, just because it's not only perceived as complex, but it can be complex. Many systems do use a radius-based solution at the core. So that means that you have to actually have someone with the appropriate skill sets to actually implement 802.1x or radius on your network. It also means that many or all of your network devices will have to be configured and integrated with radius. On top of that, if you do implement that kind of a solution, you typically will be introducing a single point of failure. So now high availability is required. That has to be configured and validated. And all of this basically leads to a very high touch, very lengthy deployment. And sometimes these get started and just stall out. One other item that is more indicative of a legacy NAC solution is the lack of really detailed information about devices, especially relative to IoT, and just basic fingerprinting is provided. So that may not be applicable or valuable enough in certain environments. So when we think of a next-gen NAC solution, we want to address most or all of those challenges that is experienced with a legacy NAC implementation. So some of those benefits and features of a next-gen NAC solution should be that you're not tied to any particular configuration requirement or enforcement method. So for example, no requirement for 802.1x. Make that optional. You should not have to go out and configure all of your network devices. You should not be introducing a single point of failure. And you should be able to rapidly deploy NAC. If you have a cybersecurity plan that you want to implement and you're trying to get visibility right away, then you need to be able to do it quickly. You need to be able to do it with minimal staff. And then lastly, you want to have detailed information about what's connected to your network. So what we consider device platform intelligence goes beyond basic fingerprinting and provides that low-level detailed information about those devices. The Genians NAC solution we'll be talking about here more today can address all of this, and really at the core is the device platform intelligence is at the core of this solution. So we talked about surveillance and then control and automation being the building blocks of NAC that correlate to cybersecurity requirements. And device platform intelligence really is at the core from a visibility standpoint and is unique to this product relative to some of the other products out there. And the important thing about that device platform intelligence is the more information you have about the types of devices that are connecting to your network, the better decisions that you can make. Of course, there's other features that come with the control component, whether it be BYOD guest, IP address management, switch management, wireless security, endpoint management using agents, etc. However, we consider the core of any good cybersecurity plan or NAC solution to be visibility. So when you talk about surveillance of the network, you want to make sure that you have the proper coverage, meaning it has to cover both wired and wireless. It has to cover all of the areas of your network. It also has to be able to cover managed and unmanaged devices. So just like, for example, an agent implementation is going to leave out BYOD and unmanaged devices, and especially IoT devices. So you want your coverage to span across the entire network and include all devices, all active nodes on the network. Then during that detection phase, you want to be able to know who, what, where, when, and how relative to connectivity, and of course, record compliance status with any of the configured security policies. You want to be able to easily identify and observe non-compliant, unknown rogue devices or any other misconfigured devices that may be sending out abnormal traffic or causing other network issues. So device platform intelligence by Genians provides low-level detailed information that can address these core components of any good network surveillance. So for this particular topic, we won't dig too deep into this because on this topic, we're going to be covering this during our next webinar. So I talked about this being an overview. The next webinar will be a deep dive on device platform intelligence. So as a quick overview, there are some differentiators with this besides against your legacy device fingerprinting, such as images of the actual device, which is very valuable in an IoT-centric environment, or really in any environment, having a visual depiction of the device. Information about the manufacturer, you get information about the country of origin, you get information about end of life, end of support. There's also links to vulnerabilities built in already. So the Genians Device Platform Intelligence database in the cloud has already correlated all of this information without having to have an external vulnerability scanner or other systems. And this database is maintained by a team of DevOps engineers at Genians. So this is beyond fingerprinting, and this will be the main topic of our deep dive next webinar. Also, one thing to point out is no network configuration is required to obtain this information for nodes on your network. I know that sounds too good to be true, but we'll prove it to you. So once you have visibility, then you have to control. So control is obviously a key component of network access control, but visibility comes first. Once you actually have that visibility, it's time to actually group your devices together and then tie those groups to enforcement policies and assign permissions. That's really what it's all about. Knowing what's on your network, grouping and classifying what is on your network, and that, you know, the accuracy of your visibility will depend on how well you can group those devices together, and then be able to actually tie specific permissions depending on that. So that is actually the core of what you want to do with network access control and with the control portion of the product, is to be able to assign those permissions, and it all ties backwards into your visibility. With Genians, you have many different enforcement options. We'll talk about some of those today. We won't get too deep into this because the webinar after our next webinar will be a deep dive on the control portion. But one such feature is security tag feature. So it's very easy to passively detect with Genians device platform intelligence all the active nodes on your network, and then tie those to logical security tags in the system that can be assigned to specific permissions. Those can actually have start and stop dates. So this is a real common example here where you can actually create a contractor tag and tie it to a particular node on the network. And that node, regardless of where it's connected or how it's connected, will have that specific level of privileges during that specific time frame. All of this is implemented without any requirement for network device configuration, and you don't have to be a Cisco CCIE or some other network expert to implement this type of solution. More on that in our following webinar series. And last but not least, after visibility and control, you have automation. So the reason automation is important is to be able to leverage all of the information you've gathered, all the information that you've grouped together, and be able to integrate with other security systems on your network, to be able to share information and pull information from other systems. This just increases the value of your network access control solution, and also increases the value and capabilities of your other systems that you integrate with it. So typically you're looking at sharing information with external systems. One of the most common use cases is IP and user correlation, and then be able to fill gaps for some of those other devices that don't have that correlation, and then receiving information from those devices, like an IDS, for example, to take information such as a device that has been hit on a malware threat or an active threat signature, and to be able to block that using the inherent blocking mechanisms built into network access control. Two brief examples. This would be an example of the ability to publish information that is gathered by your Genians NAC network access control system to an external system that can use that because there's a gap in its information. Because of where a firewall sits in the network and its lack of ability to always correlate users, especially with unmanaged devices, the lack of ability to correlate users with IP addresses, and therefore the lack of ability to craft specific security policies and bandwidth quotas, because the only information available is an IP address. This integration allows the IP and user correlated data captured by Genians during the authentication process and leverage it in a Palo Alto that can assign a actual tag to that particular user, an IP address, and now it can craft specific firewall rules relative to security policies or bandwidth quotas to an IP address, just like it's a user. And that is a huge advantage with your Palo Alto, and fills a big blind spot that it has in its data by default. Another integration option is in the reverse direction, where we integrate with an external system that has a threat engine database and is identifying threats in real time, but because of where the device sits or because of its limited capabilities, can't actually quarantine the device properly or sufficiently enough. With this integration, we'll actually take some type of alert. It can be syslog, it can be any kind of generic format, and that gets ingested by the Genians NAC and will match on a security policy. Typically, if it's a severe alert, the policy is to quarantine the device. That includes quarantine the internet. That also includes quarantine east-west traffic, meaning that device cannot talk to any other device on its same local segment. So that is an example of how you can enhance both the value of your Genians NAC solution and perhaps an external IPS solution by extending its capability to quarantine devices at the edge where devices connect.
Right. Great stuff, Brett. It's clear that you have a great wealth of knowledge and experience with NAC. You've deployed it in many environments over the course of your career. And it certainly seems that NAC is the ideal solution for controlling all connected devices at the edge. But for a given organization struggling with network visibility and access control, just how easy is it really to deploy NAC these days?
Well, I think we mentioned earlier, very early on in the webinar about the challenges, right, of legacy NAC solutions and being able to implement those and how that may prevent or stall out proposed projects, which leave companies vulnerable. So because of that, NAC itself is really, as we showed earlier, is a direct correlation to how you can solve your cybersecurity, your core cybersecurity requirements. So it becomes an easy decision to make, but then how you actually implement NAC is almost more important than the fact that you do implement it. So 90% or almost 100% of your NAC integrations are typically going to fall under one of these categories. I really don't talk about agent-based because this is more of a network architecture matrix here, but this gives you an idea of, depending on which architecture you choose, what kind of challenges you may or may not be facing with each architecture. So they all have their pros and cons. However, you can see from at the very left side of the matrix is really the more complex type of architecture, and to the right is the easiest kind of architecture. So the fact that you actually have this comparison allows you to take these considerations into account when you're making a decision. So the answer is that you can quickly and easily install network access control, but it can also be very complex based on what architecture you choose. Genians NAC supports all of these architecture models, but we talk mainly about the sensor approach because we believe that is really the key to a next-gen NAC solution and solves so many of the problems documented here. One quick comparison. In a typical radius NAC deployment, it's a very high touch deployment. So what you have here is the situation where you have to touch all of these different devices, components on your network just to implement the basics. So switch configuration, wireless controller configuration, access point configuration. You introduce a single point of failure, so now you need high availability. That adds complexity. So by the time you do all of this, you're talking about a pretty intrusive integration. There's also going to be some basic requirements for these network components. So this is not a vendor agnostic or neutral implementation by any means. You will have minimum requirements for those network devices to be able to use this. So this is a very challenging environment. In contrast, the sensor-based solution really is, I won't say zero touch, but it is very low touch. So with this type of an integration, you don't have to actually touch all those components on your network. In fact, you can implement this solution and not even know what those components are. So it makes them totally irrelevant. So truly, in the very sense of the term, it is vendor agnostic or vendor neutral. What this basically boils down to is the ability to do a rapid deployment, and we talked about that earlier. That's how you actually get your project off the ground, secure your network quicker, and rapidly deploy at the edge. The ARP enforcement model that we recommend that you use with the sensor-based approach is something we'll do a deep dive on 2 webinars from now. So be sure to attend that if you're interested in learning more about that. This can also be deployed in a cloud-based model where your policy server sits in the cloud. So if we put all this together, how do you actually deploy what we've talked about? And how do you ensure you're successful? So having a deployment plan that actually groups all this together, puts it in order, prioritizes it, allows people with very little or no network access control experience to be successful. So as long as you follow this roadmap and you go through and you follow the steps in each phase, then you're going to have a successful deployment. So if you combine this methodology with the ability to have high-level network engineers implementing this, it becomes much more attractive for someone responsible for cybersecurity for an organization to actually implement a project like this, knowing you have a roadmap and a plan, and also knowing you don't need to have highly experienced people to implement it. So summarizing some of the topics we talked about today, and some of the most important things is visibility. So we talked about how visibility is really at the core of everything. Our next webinar will actually dig deep into visibility and Genians device platform intelligence. So be sure to attend if you're interested in that. And then control and then monitoring. So really, if you're talking about cybersecurity, that's how network access control can help you implement a successful cybersecurity plan, because those are the same core requirements. The other thing to remember today is how directly the network access control components and solutions directly align with those cybersecurity requirements, regardless of what regulatory compliance you're talking about or what industry you're in. All of those basic, half a dozen requirements and recommended steps, those are all inherent to NAC. So if you can find, the ability to implement NAC, you're going to meet most or all of those requirements. One of the primary inhibitors of that has been how challenging NAC has been. So if you can remove the challenges of implementing NAC, then you're going to have an easier deployment. You're going to have a higher probability of being able to successfully secure your network in a timely fashion from the inside out. And of course, today we know that most of your threats originate from the inside, and that will give you a successful cybersecurity plan and lock down your network appropriately.
Excellent, Brett. Thank you. And with that, let's take a look at some of the questions that have come in since we began. One from Ashok is really a matter of clarification, where he's indicated that radius means 802.1x, right?
That's a great question. So when you talk about radius and 802.1x, many times they get used synonymously, which is not actually always accurate. So radius is a standards-based protocol. 802.1x is one of the authentication mechanisms. However, there are radius implementations that do not involve 802.1x at all relative to the type of authentication. For example, you can do a MAC-based authentication through Radius, and the MAC-based authentication could be an IoT type device or some device that really doesn't have any other way to authenticate except through its MAC address. So sometimes it gets a little confusing because of the way that the features are worded on various network devices. They may say enable 802.1x or enable Radius. So in some ways they get used as synonymous terms, but there are some kind of critical differences there where 802.1x is perceived as more type of authentication, and the MAC authentication is really separate. So just the devil is in the details with those.
Right, absolutely. A few other topics have come up. One zeroing in on just exactly what the difference is between, say, NAC, which obviously is focused on access, and the firewall appliance, which clearly has that focus as well.
Sure. Well, what we talked about was where NAC is positioned. So NAC is positioned in the network with the ability to layer 2, typically isolate the devices from the rest of the network, even from neighbors on the same segment. Because of where a firewall sits out on the perimeter of the network, a firewall itself may be able to shut down threats at the perimeter, but it's just not going to help you secure the rest of your network and still leaves you exposed. So firewalls are great at what they do, but they're not going to meet your requirements that we talked about, those core cybersecurity requirements, because they just don't extend out to the edge.
Absolutely. So here from another person, on the matter of assigning different levels of access to users or devices, can NAC be easily used to assign different levels of user and device access when somebody's already been authorized on the network?
Absolutely. So, for example, you think of network access control, you think about blocking unknown, rogue, or unwanted, unauthorized devices from the network, which is certainly a core component of NAC, but really assigning privileges based on criteria that are unique. For example, if Michael connects to the network with his mobile device and Brett connects to the same network only with his corporate issued laptop, those permissions could and should be different. So role-based access and different levels of permissions for even authorized users should be implemented, and really that rolls into some of the best practices of a zero trust model, which are least privilege access required, meaning don't give any more access than you should have. So you can absolutely do that with NAC.
Right, great. And finally, you know, one of my questions originally when I encountered NAC was, what about other security systems that might already be deployed on my network? I may have something from Palo Alto or Juniper or Cisco, you name it, right? If I've got some, say, a SIM already deployed on my network, how can NAC work in concert, or can it, with those other security systems to increase my overall defensive bulwark?
Well, that is a very common feature. It's part of the automation feature we talked about. So that's the ability for NAC to integrate with third-party devices. So we gave a couple of examples with the publishing data with IP user correlation to Palo Alto, or taking a feed from something like a FireEye and quarantining a device at layer 2. So that is something that you should definitely leverage with your NAC system. Your NAC system should be able to do that, and it should be able to do it with as many different devices as possible. But the more value you can get out of those interconnected systems, the better, and those features are absolutely available and should be used if possible.
Right, Roger that. We have certainly have time for another one, and one's just come in from Kushanga. Is the Genian solution similar to PAM? P-A-M.
The difference between from Genians is that it's actually it's really a full and complete NAC solution. You know, all the way from the device platform intelligence information that you actually get from the system to the ability to do your typical NAC-like functions with grouping and permissions, and then integrating with third-party solutions that we talked about, and also to be able to do it all in a passive manner. So you're collecting the information, you're doing basically asset management discovery, and device platform. We don't want to use the term fingerprinting because it's much more beyond that. You're categorizing all that, you're assigning very specific permissions, and you're doing so at the layer 2 level, you know, with ARP enforcement, without any reliance on your network infrastructure, or without relying on a feed from anything else. So that's what differentiates it from PAM. It's a fully functional, full-featured NAC solution with all those capabilities.
Okay, absolutely. Okay, well, that's everything we had lined up, folks, for today's webinar, where we've had the opportunity to go over the various challenges facing NAC in the enterprise and our enterprise users, the increasingly complex and important array of requirements that must be met to achieve effective access control, and the need to bring our environments up to the capability levels offered by Next-Gen NAC. In our next webinar, we will learn more about how Genians can deliver these next-gen features, including reviewing via a live demo how Next-Gen NAC significantly enhances network device visibility and overall observability, something that is, of course, increasingly being recognized as critical in the world of IT, OT, and also multi-cloud environments. Before, though, we sign off, I see that Ashok has one more question. Thank you. Is it possible to use multiple enforcement methods in a single policy server?
Yes, that's a great question. So one of the things we talked about was the ability to use any of the aforementioned enforcement mechanisms, whether it be radius, SNMP, port mirror, or sensor, and be able to use those, any one of those enforcement methodologies. So you definitely can mix and match. So a perfect example is if you have an environment where you don't have the ability to install a network sensor, but you have a concentrated area where you still need to enforce policy on traffic, you can use the port mirror solution, which you can basically configure on your central policy server, but also have sensors at other locations or in your headquarters for the sensor-based enforcement. So you have a policy server, which is basically the brains of the operation, and then you have sensors or mirror enforcers, and you can combine the ARP enforcement and mirror enforcement together. That's a great topic for our webinar, 2 webinars out, which is going to drill down on and focus on with a live demo the different enforcement methods. So if you're interested in that, by all means attend that. And then of course the next monthly webinar will be more on the visibility device platform intelligence, and that will also include a live demo for that particular feature.
Great, a good teaser, and we hope that'll inspire people to come back and ask more great questions and learn more about this space. Thanks very much, Brett, for illuminating us with regard to this this technology today. Thanks to those who were able to attend our webinar, and thanks to those who offered up some really great questions for us to address. Until next time, this is Michael Clark and
Brett Hamill.
Thanks very much, everyone.